Pandas Read HTML is a fast and convenient way to scrape data from HTML tables and deliver it in a readable Pandas data frame format. Want to see how that happens in practice? Let's take a look at a detailed guide on how to start with Pandas Read HTML. Before we move on to the tutorial, it's important to define what Pandas is and why you should use it. Pandas is an open-source Python library, which is easy to use, has exceptional performance, and is suitable for data analysis of various data formats such as Excel, JSON, CSV, and others. One of the most useful functions of this library is Pandas Read HTML, which allows you to convert HTML tables into Pandas data frame. By organizing your data into a two-dimensional table with rows and columns, this structure makes the data readable and more presentable. To begin the actual HTML tables extraction, we first need to install Pandas. Pandas can be installed using Anaconda, an open-source distribution for Python and R that also includes Jupyter Notebook, which we will use as our editor. If you wish, you can install Pandas without Anaconda using pip install pandas. You can also install Jupyter Notebook by running pip install notebook. The page we'll be working with today includes the list of the wealthiest Americans by net worth. You can easily find it on Wikipedia with all the data we need in a table. One thing you have to know before starting with Pandas is that they work only for the pages which contain the data in the HTML table. Let's start by opening Jupyter and creating a new notebook. Then, import Pandas by typing in import pandas as PD. The function we will use is Pandas Read HTML. We can press a Shift tab to view the signature where you can see that the first parameter is the file path or a URL. Below, you can of course find many more parameters, such as match, flavor, header, and so on, but we will look at those shortly. Now, let's store the URL in a local variable so that it's easier to work with. Enter Pandas Read HTML and send in the URL. As you can see, we were able to extract all the tables with only one line of code. However, there are several other things you will need to take care of. At the very top of the table, you can notice square brackets that indicate that the results are actually a list of data frames. Let's store them in a variable called df. After running the code once again and checking its length, it can be seen that it has returned 10 results, but the page itself contains only one table. This is due to the fact that the page uses the table elements for all the other information included on it. But we are only interested in the first table, which contains such information as rank, name, net worth, source of wealth, date of birth. A simple way to locate the specific table is to look for the first element in the list and print it. This way, you can keep looking at all the elements and see which one contains the data. Note that this approach will be difficult if you have a huge number of data frames in a list. In this case, we were lucky, and the data was located in the first table. Later, I will also show you other parameters that can help you to locate this table. But before we continue, pay attention to one more thing. The date of birth column contains only partial data. This can happen due to many reasons, and one of the main ones is the subtle difference in how various parsers treat HTML. You can experiment with the flavor parameter to use a different parser. By default, LXML is used, but we are going to change it to BS4. It is important to ensure that Beautiful Soup 4 and HTML5 parser are installed. You can run pip install Beautiful Soup 4 and pip install HTML5 lib. After that's done, we run the code. The length of data frames will still be the same. Now, looking at the very first row of the first data frame, you can see that the date of birth appears correctly. As date of birth is infinitely more useful than age and date of birth in one string, let's extract it from the string that we have in the data frame. Store this first data frame into a variable so you can work easily. Then, take the date of birth age column and use the ctr.replace method that will search for the text that we specified as the first parameter, and replace it with the text given as the second parameter. We cannot use a simple replace as the age is different for every row. What we see though is that the age is in parentheses. The solution is to use a regular expression that can find parentheses and everything in between. This regular expression will be opening parentheses, dot and asterisk, and closing parentheses. Let's use this regular expression and send it to the first parameter. The second parameter is what we're going to replace it with. This will be a blank string. Lastly, the regex parameter also needs to be set to true. Without setting this parameter to true, the find will look for the exact string, which will fail. Run the current cell and you will see that the dates appear correctly. Update the existing column of the data frame with this column, preview the data frame, and you can see that all the dates are now correct. Now, call the df.info method to see details of the columns such as data types. We can see that even though the columns are valid dates, the type of the column is object, which means that the dates are stored as strings. Let's change that. Call pd.toDateTime and pass column as the parameter. Now, if we look at the date of birth column, we can see that the date is formatted differently. And lastly, if we look at df.info, we will see that this column has changed to datetime64 data type. In other words, now it is a proper date time. Now, time to cover one more scenario, scraping only a specific column. Continuing the example from the same web page, let's scrape only the names of the billionaires. First, use the read.html function to create the data frame. To keep things simple, make a copy of this notebook and delete all the unwanted cells. Now, we can execute all these cells to create our data frame. Note that the column that we want to scrape is name. We're going to use Pandas filtering to select this specific column using the square brackets. While a pair of square brackets return a series, the double square brackets will return a data frame, and that is exactly what we need. For the next stage of our Pandas tutorial, let's take a look at one more example web page. It has only one table, which I will show you how to extract. Let's repeat what we did in the earlier examples. Call the Pandas read.html method and send the page URL as the parameter. Execute it. Now, check the length of the results in the DFS variable. You can see that there are 8 tables. We can extract a particular table by searching for a text in the table and get the ones that have a match. For example, let's search for the number of billionaires. We need to send this text to a parameter called match. Let's run the code. Upon checking the length, you can see that the length is 1, which is what we wanted. If we look at the data frame, the header spans 2 rows. The reason is that if you look at the HTML of the page, the table has th in 2 rows. Pandas creates a header index for every row that has th elements. Let's return the code and use one more parameter of the red_HTML function. This parameter is called skip rows. To skip the first row, we will set the parameter to 1. We run the code, and now the first row of the header is discarded. However, now there is another problem. It has skipped the first row, but the header still takes up 2 rows. The solution is straightforward. We can set another parameter header to 0, meaning we want only the first row as the header. If we look at the results now, we have resolved the problems. We can do as much cleanup as we want. For example, we can use str_replace to clean up the square brackets. Now that you've learned how to read HTML tables with Pandas, let's see how you can export the scraped data to CSV. Data frames can be exported to XLSX or CSV using built-in methods. For example, to export a CSV, call df.toCSV. We need to provide a file name. Let's use billionaire.csv. If you don't want indexes to be exported to CSV, set the optional parameter index to false. Let's run the code, and we can see that the CSV file with all the data is ready. Note that in case you're using Python Beautiful Soup for other web scraping projects, you can watch another video demonstrating how to extract scraped data to Excel that you can now see at the top right corner of your screen. So, in today's tutorial, we presented a detailed example of reading HTML tables with Pandas. In addition to showing you how you can use Pandas Read HTML to extract tables from web pages, we also demonstrated several other commands you can use, such as parsing dates, skipping rows, scraping only a specific column, using match to find a table in the page. The code samples for reading HTML tables with Pandas are also available in our GitHub repository. To access it, follow the link in the description below. I hope this video tutorial was useful and you will consider following it as an example for your future web scraping projects. And of course, if you have any questions about the process of starting with Pandas Read HTML or want to learn more about any other web scraping topic, don't hesitate to contact us at hello@oxylabs.io or simply leave a comment below. Don't forget to subscribe to our channel to see more educational content from Oxylabs and share this video on your social media. Thank you for watching.